Hello kids, today we are going to do chapter 9, reflection and refraction of light. So today we'll just focus on the reflection of light, concave mirrors, and the important terms that are used in this chapter. And in the following video we'll have more on the concave mirrors, the image formation, or the reflection of light concepts on concave mirrors. So first of all, let's draw one concave mirror. Okay, so this is my concave mirror. This is the back side of the mirror. The line shown here shows that this is the back side of the mirror. You see how this ulta C is there? It's like enclosing something. So this is concave mirror. Here remember the shape, bent inwards. Now this concave mirror, you can draw an imaginary sphere, right? It's a part of a sphere. So this is our imaginary sphere here. Okay. Now, since it's a sphere, it will have a center as well. Should it have a center? Yes, it will have a center. Now, this is called center of curvature. It's denoted by C. Okay. Now, let's say this, let's name these parts as M and N. This reflective parts. Okay. The distance this to this here is M to N. Okay, now between M and N, there is a center, right? So this center is called as the pole. So the next term that we are using here is pole. So let me write it in the same color, green. Okay, so this is pole. So this is, so what did we see? We saw pole, we saw center of curvature. Okay. Now remember, the center of curvature is an imaginary thing. It's not a part of the mirror. Okay. Like we said, there's a sphere and this is the center. So center of curvature actually is not a part of the mirror. Now, the next thing that we need to know is the radius of curvature. Now, this center, we know in a circle or in a sphere, this is the circle, this is the center. So this becomes the radius, center to the periphery, right? So now this C to P becomes what? From center to the pole becomes the radius of the mirror. We denote it by the R, capital R, and it's called radius of curvature, of course. Okay, now imagine there is a line going through P and C and beyond. Okay. Now this is called as the principal axis. Okay, so this is called as principal axis. And remember, this principal axis is normal to the, or is at 90 degrees to the pole. Okay, to the surface here, where it touches the mirror at the pole. So it is also called as normal. Okay, normal to the mirror at P. It is also called as normal. Now, principal focus, F. What is principal focus? Principal focus lies here, between pole and the center. Okay? This is where actually the convergence of rays happen, at F. That is principal focus, because it's lying on the principal axis. It's called principal focus. Okay, this is where actually the convergence of rays happens. And then there is something called as aperture. Aperture is actually the length of this active reflective part of the mirror. Okay, which is M to N in our case. So this part. Okay. This is our aperture. How big is the aperture? It's almost same as the diameter, right? If you look at it here, I draw it like this, all the imaginary things here. So if you look at it, it is same as the diameter. In case of small mirrors, the mirrors are larger, then this changes, right? So in our case, in our syllabus, we have this aperture is almost same as the diameter. Okay. And what we know about aperture is, since this is the active reflective part, so if this is bigger, it reflects more light, and if it reflects more light, the picture is brighter, but there could be distortion at the ends. If this is small, the picture is sharper. Okay. So these were some of the important terms. And before we move forward, I'll just add it here that radius of curvature, I'll put it in red. R, okay, now I forgot to tell one thing. This is focal length. So there's small f. Small f is focal length. What is focal length? It is the distance between the pole and the principal focus f. And this is actually a measured thing. So it will have a unit like centimeter, meter or something. Okay? So this is focal length. And there's a relation between focal length and radius of curvature. So R is equal to 2F. What does that tell me? That F lies in the center of C and P, between the pole and the center of the mirror or center of curvature. Okay, so this you remember. So this was about the important terms that we are going to be used in this chapter. Okay, so switch on to my next video to learn more about reflection of light, and the focus will be on concave mirrors. Thank you.